Hi everyone. So we've been talking about light and electrons and how they will release a photon. As we know, Bohr's model did a great job at explaining how a hydrogen reacted, but not any other atom. So in 1924, a French scientist named Louis de Broglie proposed an idea. He believed that quantized electrons and their orbits had characteristics like those of waves. He saw that only odd numbers of wavelengths were allowed in circular orbits. He then created an equation that predicts that all moving particles have wave characteristics. Don't worry too much about the equation, but here's an explanation of it. The wavelength of a particle, which is our lambda, equals Planck's constant, as we know as h, divided by the product of its mass by its frequency. Due to this, other experiments have proven that electrons and other moving particles do indeed have wave-like characteristics. Scientists, step by step, kept unraveling the mysteries of the atom. However, a conclusion reached by Werner Heisenberg proved to have a profound implication for all atomic models. Heisenberg showed that it was impossible to take any measurement of an object without disturbing it. The act of observing the electron produces a significant, unavoidable uncertainty in the position and motions of that electron. Due to this, Heisenberg came up with his uncertainty principle, stating that it is fundamentally impossible to know precisely both the velocity and position of a particle at the same time. This also means that it is impossible to assign fixed paths for electrons like the Bohr's model had thought. To continue this research, in 1926, Austrian physicist Erwin Schrödinger furthered the wave-particle theory, which treated the hydrogen atom's electron as a wave. This new model for the hydrogen atom seemed to apply equally well to all other atoms and of elements. This model became known as the quantum mechanical model of the atom. In this model, electrons are treated as waves, and electrons' energies are limited to certain values. Due to the wave function, the electron's probable location can be known. Look at this photo. The high density of dots near the nucleus indicates the electron's most probable location, but it might be found somewhere else in another distance from the nucleus. Your atomic orbital describes the electron's probable location. Due to this, your atomic orbitals also have different energy levels of electrons as well as their shapes. Their shapes are an S, P, D, and F. Your S orbitals are spherical in shape. Your P orbitals look like dumbbells. Your D orbitals can have several shapes. Some might say like a snowflake, and your F orbitals are very complicated. If in your S orbital, you can only have up to 2 electrons. In your P orbital, you can have up to 6 electrons, and in a D orbital, up to 10. And in an F orbital, you can have up to 14. You are now going to watch a second video on how we write the possible location of electrons in an atom, which is known as your electron configurations.